Hello and welcome everybody to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz. And I just want to say thanks very much for joining us today when we look at our topic and presentation regarding data and data collection. I've been here with Mountz for over 15 years now. I've been in the torque industry for approximately 20 years or so. And so we'll take a look at what we can find in today's discussion, and I hope you find something that useful for you as well. Now, as with every webinar, the participants will be muted. However, if you want to ask a question, we will have a time for question and answers at the end of the presentation. Feel free to go ahead and put that into the chat, and we will try to answer your question right now. If there is some reason we can't, we'll certainly get back in touch with you to be able to do that for you as well. And so let's go ahead and get started. First, a little bit something about Mountz. Mountz has been in business for over 55 years now. We are solely a torque-based company or torque-focused company. So all we do is everything that we do is around torque. And so we have three separate locations here. In our corporate office is located in San Jose, California, along with our Western Service Center. We have our distribution and warehouse facility located in Foley, Alabama. Then we have our international sales and service office located outside of London, England. And so that is kind of our global presence at the moment. And today's discussion will be talking about manufacturing data collection. This is a big topic right now with Industry 4.0, also with the Internet of Things and being able to communicate and being able to take advantage of the certain MES systems that may be available to you. And so we'll go ahead and just jump right in. Now, when we look at the discussion of data, this goes hand in hand with what we talked about last month and our lean manufacturing discussion and the 3 M's of lean manufacturing. And so if you're familiar with lean manufacturing, we know that if we can get our facility to be at a more constant path for our specific product to move from a raw good to a finished good, if we can get that path to where there is no delays for that particular application or product, and we can move that straight through the factory, that is kind of the ideal situation. And in many cases, we have areas where that does not happen, and that's represented here by our Mura, which would be our first M in the 3 M's of lean manufacturing. And so that's basically just the unevenness that would surround that total capacity. And then we take a closer look at everything above the line would be considered Murray, or something that's putting a burden on the process, where there's been some overwork that may be attributed to machinery or different holdups and things like that. And then we have everything that would be below the line, which is the muda, or the waste that is generated. And we looked at the different kinds of waste as far as transportation and the waste of waiting, all those different things that that we looked at for that. And so for us to kind of try to make this curve as close to the line as possible, if we can take a look at those particular areas where we're seeing waste happen or overburden, and we can shrink those, that's going to help us get to a more smooth type of result with the manufacturing. And to be able to do that effectively, that does require data for us to be able to look at. And so with today's discussion, and we're looking at the manufacturing data collection process. And so in general, when we have the ability to collect data around the what's happening with the lines or with the workflow, that gives us the ability to kind of gain visibility on certain areas where we may be seeing effective or ineffective work. And with that information that we're going to be gathering, it gives us the ability to make good decisions, and the right decision that would be driven from the data. And in turn, that will help to increase productivity. And in the long run, where we really want to be is having the ability to increase the profit for the particular fastening application or the entire assembly process. And so if we look at the benefits of collecting fastening data for specific systems, the big, I guess, benefit right off the bat is being able to record and store data from the torque and fastening applications. And so if we can do that, that's going to help us to be able to reduce waste. We'll be able to see where we maybe have situations where there may be errors that may be causing rework needs. That rework then is considered waste in the lean manufacturing. Does the part need to be redone? All of those things as it relates to the fastening process. And again, the data that we would be receiving from the fastening information allows us to make good decisions about certain processes, and if a certain area is overworked, or if there is a need to increase that particular application process. So with the ability to be able to collect data and monitor that, that's giving us the ability to have a faster response to certain issues that we may see, which is going to actually improve the benchmarking for a product assembly, and then also the actual product itself, where we can optimize and help to improve the process. And optimization, again, may not necessarily mean that we're doing things faster, but we're doing them more efficiently, and we're doing them within the time that is needed to help move through the process. So if we look at the ability to collect data as it relates to quality control, if we do have that ability to monitor what is happening with the tool itself, that's going to give us the ability to correct an error right away if that particular system gives us a fastening error. And with that, we're going to be able to help eliminate processes down the line that may be affected by a particular error that may have gone unnoticed. And that could be errors like possibly a missing fastener, could be maybe a cross-threaded fastener as well that doesn't get noticed until we're 3 or 4 steps down the line. If there are missing washer stacks or other components that needed to be within that. So for us to be able to have that ability to monitor and see if there are errors, this is really going to help to mitigate the ability for us to produce defects and help us with our quality control. And so let's go ahead and take a look at our poll, one of our poll questions today. What is your organization's key reason for recording fastening data? And so we've got our assistants here, either Chris or Casey or Pinka will be launching that poll. So if we could go ahead and do that.
There you go, guys.
All right, very good. So we have internal quality requirements. the government regulation and compliance, process and productivity analysis, as well as data records and quality audits, and equipment history and predictive tool maintenance. All right, so we'll go ahead and give you just a couple more seconds here, and then we'll continue on with the demonstration. But it looks like the majority here is for us to be able to capture data records with the quality audits by customers. So thank you very much for that. We've got one more poll question that we'll be asking here in just a second, but let's go ahead and continue on with the presentation. So when we look at the ability to be able to capture the production records that happen for the fastening process, this really helps us to be able to do a lot of different things with those particular records. If we do have, as some of you indicated, the ability to have those records for quality control audits, either by a customer or maybe even an ISO audit, that gives us that ability to have that information readily available and to be able to share for those particular audits. We also have the ability to actually link specific fastening processes to a specific product ID, product assembly. So that gives us another benefit of being able to actually not only have the time and date for a specific application, but we can actually go ahead and link that particular fastening to a specific product or build for the assembly process. And so that really helps us, again, to be able to narrow down the focus and see which actual product was built at that time with the torque values that we are seeing. And all of this helps us to be able to limit the liability for what we are producing, to help against any type of claim that may come back from a customer or an end user about this particular product wasn't tightened to a certain spec. If we do have those particular production records with all of the fastening data from that, we can go ahead and we'll have that to be able to protect us and indemnify us from those types of inquiries. And so let's go ahead and take a look at our next poll question. When you're looking for your fastening data, what key metric is the most important to you? So we'll go ahead and launch our second question. And we'll give you just a few minutes here to go ahead and select your answer. Well, we look like we've got all of the above is coming out on top from the applied torque to the fastener, the total rundown time, our total measurement, the rundown success, and the number of screws that were run down as well. So all of the above was our majority, and so that gives us a good place to start as we take a look at the next portion in the presentation here, as we look at the way that smart torque control systems can help us with our need to be able to capture this type of information. And so the first way we can do this is with the use of a torque analyzer and a rotary sensor. And so the torque sensor there goes between the actual tool and your assembly part. It's basically part of the assembly. And so this can be used with different tools, although the primary focus for data collection is done with DC control tools. There is the way we can do it with either manual torque screwdriver, manual click wrenches. We can also do it with standard electric clutch tools, pneumatic tools, and also pulse tools as well. So this type of ability for us to be able to capture the torque data for what's happening with a non-DC control tool, that is possible. So in this case, we would run the tool until it completes its rundown. The system then would capture that torque value, and then it will go ahead and be stored into the analyzer, or we could stream it out through a couple other different processes that are available with this PTT that we're working with, and a rotary style analyzer. And so if the DC tool is not there, you still want to be able to capture what's happening on an assembly process. We can do that with an analyzer and a rotary sensor. But if we look at the DC control tool, this is where we have a lot more flexibility and a lot more control with what we can do as it relates to data. And so most of what I'm looking at for the different types of data that we can get is, I would assume, most DC control tools are going to have some variation of these different items. However, I will speak on our DC control tools, which we have our EC, our ECT, which is our corded version of our control tools that have a transducerized system in the ECT, and then we have a current control for our EC product. We also have a wireless DC transducerized battery system as well. And so all of those would fall under what we'll be looking at, excuse me, here in just a second. So the first item that we have here is if we're using a transducerized system, that gives us the ability to have basically the sensor that we looked at here in our last example with the analyzer. We've actually now put the transducer inside of the torque driver, and we're able to measure straight from the tool to the controller. And so having that ability to be able to measure that gives us that torque data that we would have gotten from our torque analyzer. And so with this is going to ensure that we've got really good torque control. With that, we have the ability to do real-time monitoring. And we'll take a look at some of the different characteristics of the different data sets that we can monitor. The system allows us to be able to integrate this into line controls with PLC and other communication devices. With that, the ability for collecting all of the processes for recording and storing the torque and fastening data. There are a number of different ways that we can get that information, and we'll talk about that here. So the different types of data that we can get. So first and foremost, what most people are looking for is going to be the torque data. And so what we would see as it relates to that, we're going to see which preset that particular value has. So if it is preset number 1, it's going to show what that preset torque value is. And then after the assembly has been finished or that fastening has been done, it's going to display what the final torque value is for being able to capture what has happened with the torque. Next is going to be the barcode information. And so the barcode allows us a couple different ways of operation for the barcode itself. And so we can use the barcode to a barcode reader to scan a barcode. That barcode can provide us with a preset. So we can link a barcode to a preset. We can also just scan any barcode. And after we have scanned that, all of the torque data that we capture after that is going to be associated with that particular barcode. So this gives us that ability to link the particular product or a specific part or a specific assembly of a larger component, that we can tie that specific barcode to that particular assembly process. And so that particular barcode does not need to be taught to the system. It will just read it, and then it will include that barcode in the data field. So that's how we can use the barcode, not only to select a particular preset if we like, but also be able to link the fastening data to that specific barcode. Next is going to be the time and the date that this happens. The system is going to capture that information for us. Obviously, that's very important within the data collection process. And then we can also measure the total amount of angle that happens during that particular rundown. And this is really important if we are doing additional layer of error proofing for the assembly. So with our system, we can not only look for a specific torque value, but we can also make sure that that particular torque, when achieved, that the fastener has completely gone and seated to the correct amount of angle. And so we can create an angle window. We can say that a fastener must turn at least this number of degrees, and it can turn no more than this number of degrees, and we can create a window for that. We could use just the minimum angle must be met or the maximum angle must be met. So we can have a lot of different flexibilities as it relates to how we measure angle with that. And so there are a couple different measurements that we look at, but within that, we can measure the total amount of turn for a specific rundown. Now, the way we can get the data out of the controllers, there are a couple of different ways. If you have an MES system that you would like to be able to interface with, we can do that through either a Modbus or Open Protocol to be able to call for whatever data field that we may want to pull from the controller. So that can be done. The system will automatically send that once the fastening process is done. But for example, if you don't have an MES system, you don't have the controller put onto an internal network, but you still want to have the ability to capture what's happening with your assemblies, and you want to be able to have that torque data, we can do that as well with an SD card that is stored on the controller. And so after every operation or event change, information is being sent to that SD card, and then periodically on a time interval, that card can be removed from the controller. The information can be downloaded, and then the controller or the card can be reinserted into the controller. And so there are some settings in the controller itself that will not allow the controller to function without the SD card. So you have that guarantee that the product is capturing data as it won't allow the system to run without the SD card in it. So those are the different ways that we can do that. The systems, you can either have that the data transferred via the Modbus and open protocol out of the Ethernet connection, or we also have an RS-232 port where we can run that information out as well. The battery transducerized tools currently run on Modbus only, but we also have this same type of requirements for our robotic and automation DC control tools as well. And so those are the different ways that we can actually gather and capture the data. We can also do it with the system hooked to the software as well. And I'll show you what that looks like here in just a second. And we'll go ahead and jump into the demo portion of the presentation. And so I have here the controller. And we also have our thread block here. And then I have our system connected to the controller. Currently, right now, I have this system networked on my internal network here. And so I am getting the connection through the actual network for the communication that we're looking at here. And so I've got my IP address for the controller, and we can go ahead and jump into the ways that we can look at and monitor, and I'll show you what all of the different data capabilities for us to capture. The one thing that I wanted to make note of before we kind of jump into this is that the software package that comes with the tools, there is no licensing fees that are needed for the software to run. You can put them on a number of different systems if you need that capability. So we don't restrict you in the amount of licenses that you may need or specific seats for computers. And so that never needs to be relicensed. So that's could be a considerable amount of savings depending on the amount of systems and the amount of computers that you want to be able to interact with the different controllers that you could be working with. And so if we take a look at the software itself, we have the settings tab, and in here we have the ability to set different presets. We can set some of the other fastening functions. We can look at how the controller works with different, whether it be what unit of measurement you want to deal with, a lot of different things that relate to the fastening process. But what we're interested in today is in the ability for the monitoring function. And so with that, we've got a couple different things that we can look at. First, I'll touch on the graphing function. So if I click on the graphing function here, this gives us the ability to actually graph a rundown, and we can take a look at what's happening with that particular fastener at whatever point of the process that we are running down. And so down here in the bottom, you'll see we have two different channels that we can monitor. So currently right now on channel 1, I have torque, and I can go ahead and I can change the second channel here to say angle, and we can go ahead and we can look at that. And so if I go ahead and run a fastener down, we can do that. Let me just make one adjustment to the controller. And there we go. All right, and now we can go ahead and we can do the fastening here. And so I've got the computer displayed. I have the controller here displayed as well as the thread block. So we can go ahead and do that. So right now I'm going to set to, let's say preset number 1. And I'll go ahead and I'll start monitoring the actual process. And so if I run this down, so what you're looking at here is the blue is our torque curve. And because I've got several different things happening within this particular rundown, you can see that as we get to our certain points, we hit our desired torque, which is set to 1 Newton meter. And it's showing us the amount of degrees of rotation that we saw when the item was torqued. Now, one of the other advanced features that we have is the ability to add angle after the torque has been achieved. And so that's what you're seeing down here as well, is we had additional turn of the fastener. It was actually in the reverse direction, but we did see that here as well. So we've got all of the data for the particular rundown. Here we have our time date stamp. We have our channels. We have how much time it took, the target, the RPM that we're using, the amount of angle. So angle 1 and angle 2 equals the total amount of angle. And then we have some other information here, and then different items as it relates to being able to graph a specific rundown. And so that is basically how we can use the graphing function to be able to look at what may be happening with a particular assembly. So maybe you're seeing fasteners that are being stripped or that aren't being completed, or there's some different types of inconsistencies that are happening with a particular joint. And you do have that ability to come in and get really good granular information on what's happening with that particular joint. And so that would be done under the graphing tab. So I'll go ahead and stop that. And then we'll go ahead and move over to our real-time information. And then this gives us more of what you could see if you're going to actually stream the data, or you're having information sent to the SD card on here. So we have in our information, our information tab here, we're going to have the time, the date, we'll have the preset, we're going to have the fastening time in milliseconds. We'll have in the torque section, we'll take a look at the target torque. We'll have the final torque. Again, we have our angle and speed information here. Next, we'll have our status information on what actually happened with that particular rundown, which direction the drive is in. If we are doing some screw counting, how many screws will remain with that. If we did see an error, what was that error code? And then we would also be able, we'll have our barcode information put into the last data field here. And so I can go ahead and click start here. And right now, basically what you're seeing is that we do have the information from the last rundown. And if I go ahead and I add some other information here, if I go ahead and do a rundown here, we're now capturing that. If we have an error, so you can see that our error code here is error code 305. And so we have that ability to actually see what the error is or was during that particular rundown. And so We have a lot of different ways that we can capture information. With that, if I change this information here, I can stop this. I can go to, let me just clear this. Come back here. We can do other information in regards to the ability for process control in our real-time monitoring. In this case, this is going to help us to do a actual torque study of a particular application using the tool. So we can go ahead and get our CP and our CPK information from this rundown. And so what I'll do is we do have the ability to use what's called a multi-sequence process. And I'll just show you what that looks like here real quick. And so with the multi-sequence, you have the ability to do a number of different features, but you could stack different presets on top of each other. You can do a counting type of function, but in this case, we're just going to run the fastener up and down a number of times to be able to capture the different data. And so in this process here, I can basically, if we're wanting to do a measurement of 10 different fasteners, we can do a count value and I'll set it to 9. We're going to run preset 14. In our fastening steps, we'll have a little delay. The fastener will then loosen. Then we're going to subtract 1 from our count, which was 9. It now becomes 8. And we basically created a little routine here that will run down once we get to the system where A, or the count, is going to be equal to 1. It's actually going to move on. We'll do one more fastener, we'll delay, and then that will end. And so that's how we can use the basically the multi-sequence process. And so if we come back over here to our monitoring in real time, I can go ahead and let me change to our multi-sequence B. Where I have that set, I can go ahead and hit start. And now it is monitoring that information. And so, and this will all basically be one trigger pull event. So we're kind of building our curve here as it relates to our fastening data. Okay, and so we've gone through our particular count here of 10. We had what our target torque was here at 2 Newton meters. And then we have the other information as it relates to our standard deviation, the error rate, what our CP is of 10, and our CPK of 9.5. So that is a way we can do some additional data capturing by using the process controls or capabilities within the software, doing that in real time. So let me just go ahead and I'll stop that, and we can come back out to our real-time tab. And we can, at any point, we can save this information. We can pull it up and look at it again at a different time. And we could do the same for the graphing function as well, where we can actually do a number of different graphs. We can go ahead and capture that information and save it. And it can be reviewed at a later date as well. And because I have the controller itself on a network, I can actually access the controller itself without the use of the software. Each controller does have its own web server built into it. So if the controller is connected to a Wi-Fi access point or a router, we can go ahead and we can access that information on the system as well through a standard web browser. So I'll go ahead and we'll come back to our system here. I'll just go disconnect from the software. And then if I go to my IP address for this, let me just go ahead and make a window change. And so now I'm actually on the browser for my internal network here. I can go ahead and enter in the IP address for the system. I can go ahead and log in to the tool. And so now you can see that I'm actually, I have access to a lot of the same information on how we can program the tool with different presets for the torque value that we may be looking to get. So we do have the same type of parameters that we do have with the software. We are a little bit limited on some of the other capabilities, but if you are on a system that does not have the software loaded onto it, but you are on the same network as the controller, you can go ahead and log in to the system using a web browser. And so we can do the same type of scenario where we can do a graphing here. And if I'll go ahead and come back here to a specific preset, I can go ahead and I can start monitoring that. And then I can go ahead and do a specific rundown. And you can see, again, we can go ahead and take a look at the amount of angle and then the amount of torque that we would achieve. So we do have that same type of ability to come in and do the different functions without necessarily having the software or the tool. So this can be done on a smartphone as well, if that is on the same network. But we can do the same type of real-time monitoring. And so if we want to be able to do a status change of the barcode, I can come in and I can scan a different barcode. And now you can see that our system has now updated the barcode that I just scanned. And now information related to that specific barcode is now here. If I go ahead and do a rundown, then you can see we have all of that information here. If I come in and I make a change to the actual barcode, we can do that as well. And now it's gone back to the other barcode that I just scanned. So we can go back and you can see I went ahead and made the scan and now we're at the barcode has been updated to another set of information. And so I know that was kind of a lot of information here, but we do have that type of capability to be able to interact with the different ways of communicating with the tool via the network and the software. So with that, that will conclude the presentation portion. We can now go through the question and answers. So if we do have any questions, Chris, feel free to go ahead and we can do our best to answer those.
Okay, Dave, thanks. There's a couple of questions. First one, is there a memory capacity for the DC tool for recording data?
So the memory for that is dependent on the SD card size that you would have. The system comes standard with an 8 gigabyte SD card. However, the files that are generated from the data are so minuscule that it would take months and months and months of data with the tool running all the time to be able to use that much data. So there is the ability to have a tremendous amount of space available to make sure you're not going to be running out of material or space on the SD card.
Okay, thanks. Next question. What is the reason for looking at a real-time curve? Is there like a discrepancy that we should be looking for?
So the fastening rundown, when we're looking at the specific curve itself, we may see a lot of inconsistencies or raises or excuse me, a rise or lower in torque for a specific rundown, depending on the joint characteristics. It could be, a real soft type of joint. There could be maybe the prevailing torque may be a little bit high. There are a number of different things that may happen. One scenario that we just came across was we had a customer that was concerned about the number of fastening errors that they were receiving. They were getting a lot of over torque type of values, and they were worried that the tool was not producing the way it should. So after a little bit of investigation and with the ability to do the graphing and looking at the torque curve, what we found out was it was actually the fasteners that they were receiving were not as well machined as they should have been. And so the actual threads themselves were not very well deburred, and it was generating a lot more torque than what the application required for as the fasteners were running down. And so those types of issues, it makes a lot of sense to be able to visually see what's happening during the rundown.
Okay. Next question was on the IP element that you were showing. Is the IP address labeled on the device, or how do we access it?
So that is basically set on the controller. And so if we look at the controller, we can go ahead and log into the system, and in our settings menu, or excuse me, in the parameter menu under network, we have the ability to come in and designate what the IP address is. So depending on your network, what addresses are available, you have that ability to enter in whatever the IP address that you want to use for that on the controller. And we just do the same thing on the access through the software. We would enter in the same IP address, or if we're going to be using the browser, as long as we're on the same network, then we can just enter in that IP address, and we'll be able to access the tool after we log in and put in the password.
All right, thanks, Dave. Looks like the last question might be on the barcode scanner element. Does it trigger both the fastening application and the data capturing as well when you scan it?
So it would do, if we had the preset hooked to a specific barcode, when we scan that barcode, that will change the preset. It will also populate the barcode field in the data set. If we want to be able to scan something, change the preset, but we want to add a different barcode to the data set that would be included with the torque data, then we would just simply need to scan the barcode that would be associated with the data. So If you just want to capture the data for that specific preset, we would just scan the barcode. Then that barcode would go into the data field. If we want to include a different barcode, then we would scan to change the preset. Then we would scan again to include that barcode into the data field.
All right, Dave, thanks. I think there's no additional questions.
All right. With that, I want to say thank you very much for joining us today. If you have any questions, feel free to contact us through our website at mountztorque.com. And with that, we'll see you on the next webinar. Thanks so much.